So today we'll talk about fermented vegetables, and so let us go for an introduction about what is fermented. So as I mentioned that whatever vegetables are grown and eaten by people, wherever they are being done, mostly people always have also a version of the fermented vegetables. So for example, cabbage, as I mentioned, cabbage is used as the raw material, or it is a source of your sauerkraut which is produced. So in Germany, the sauerkraut name itself came from Germany. So the origin is German. Okay, they are very mild tasting because only salt is present. Whereas in Korean version of that, which is called as a kimchi, the cabbage is mixed with, as I mentioned, the many of other vegetables are also added, spices are also added, and that is what it's called as kimchi. So whatever version it may be, the main principle behind this is the fermentation. And this fermentation process is beneficial in a way that because this is one, it's more digestible by the body, it releases a lot of nutrients, and it is much more long lasting. So instead of the fresh vegetables, fermented vegetables have a longer shelf life. So you can even store for around 1 year even without the refrigeration, provided you store in a proper conditions. Okay, so coming to history behind it, they have been found that this vegetable fermentation technique has been there for since the long years of human civilization. So the first primary thing which is mostly seen in vegetable fermentation is the salting. So only now we have all these modified versions. So since many centuries back, vegetable fermentation is being done where they just normally add salt. And especially when people were nomads, they used to travel from one place to another, these fermented vegetables were the only source of nutrients for them. So as per the history, they are saying that cucumbers were first pickled 4,500 years ago in Mesopotamia. So that is what is some of the documents which suggest. So there are a lot of fermented products and vegetables. You have sauerkraut, as I mentioned, which is from cabbage. You have fermented olives, fermented cucumbers. We have fermented carrots, celeries, beans. So mostly you have all these which are salted, and you have kimchis, you have sprouts which are fermented. A lot of varieties are there. Any vegetables, so any type of vegetables can be fermented, and they have their own benefits. Okay, sauerkraut has become a popular one as of now. Sauerkraut and kimchi, they are the two most now which are getting popularized throughout the world. So we'll be talking about the sauerkraut. So what is a sauerkraut? As I mentioned, it's a term German. It has come from Germany, German language. So it basically means a sour cabbage. Okay, so sauerkraut means sour cabbage. It is basically it's a raw cabbage which is shredded into very small pieces, and then you just add salt and you allow the fermentation to take place. So you don't add any starter culture here. The organisms are naturally present on the leaves of the cabbage, and you just allow the bacteria, the lactic acid bacteria, or the group of bacteria which can produce lactic acid, to work on the cabbage. And you can keep it for 2 to 3 weeks. After 2 to 3 weeks, you get the smell and the taste completely changes. It gives a sour flavor, and then after that you can store it. So this is what happens during the sauerkraut production. And the main reason of getting a sour flour is the bacteria work on the sour cabbage, and it releases or produces lactic acid. Okay, so the pH also goes down. So this is it's a pickling process, because as I mentioned, this only salt is added. So it is a pickling process. But the only thing is you don't heat here. It is basically you go for a raw cabbage. Okay, so the raw cabbage is shredded and you put in layers. So we used to do in the lab. So what you do is you just take a bottle. Into the bottle, you just keep one layer. So how you do for the mushroom cultivation, same way, one layer of the cabbage, which is completely shredded. And then you add sprinkled salt over it, and then one more layer of cabbage, then again sprinkle salt, again one layer. So like that, whatever the bottle range is there till the neck, the head space completely is being filled up with the layers of the cabbage and the salt. Then you completely tighten it, and you close that lid. You can keep one cloth and close the lid, and on the top of the lid you keep wooden blocks. So the reason why you keep wooden blocks is when this fermentation takes place, a lot of gas is also generated. So the lid can come off anytime. So you have to keep it in a, you have to keep wooden blocks. You have to keep it pressed for at least 2 weeks. And you will get the smell. After 2 weeks, you can always open and check it up whether you've got the sourness, etc. And if it is done, you can store it later in refrigerated conditions. So as I mentioned, the fully cured sauerkraut, we can keep it for several months if it is an airtight container and it is refrigerated, so that no contamination occurs. Okay, so here we don't have any pasteurization or any heating step which is done, and refrigeration is only done if you want to prolong the shelf life. Otherwise, you can just consume it like that. Okay, and as I mentioned, you do not add any culture here because of the bacteria is already present on the raw cabbage leaves itself. So you do not add anything extra here, but then that is also one reason why you can have even spoilage which is happening, because there are some yeast species and some microorganisms which might be present on the cabbage leaves, and they can even spoil the fermentation. So whenever you choose a cabbage and whenever you are going for shredding, you have to be sure that the cabbage leaves are not spoiled. They are very healthy, and if you have any spoiled leaves or which is not very good, you need to remove them out and then only go for the healthy leaves. Okay, so this is what is very important. And this particular about the discovery of lactic acid bacteria, the discovery of lactic acid bacteria, although its work was described by Pasteur in 1858, but only by Pedersen in 1930. Pedersen was the first person who described that lactic acid bacteria was found in sauerkraut. So Pasteur said that there are microorganisms which could produce lactic acid, but Pedersen was the one who actually found out that sauerkraut production was resulting because of the lactic acid bacteria. Okay, so these are some points of the lactic. What happened to it? Yeah. So these are some points which are seen in terms of sauerkraut. It is the origin of country is obviously Germany, and that's a name came as from German language. Major ingredients, there's only two ingredients, cabbage and salt. You don't even add water, because what happens when you add salt to the cabbage, the salt releases the water content from the cabbage leaves itself. So after 2 weeks when you take, you will find that there is salt, there is water content in cabbage in the sauerkraut. Okay, and normally usage is like a salad or side dish. You can simply have it like that. And this is a fermented product. It has a sour taste with a clean acid flavor because lactic acid production is there, so pH goes down. And the most common organisms which you found here is, one is leuconostoc mesenteroids, then Lactobacillus brevis, Pediococcus cerevisiae, and Lactobacillus plantarum. These are the most common dominant organisms which are seen in the sauerkraut product. And we don't have any starter culture, so normally the natural microflora is used. In some places only if they are going for pasteurization technique to remove all the microorganisms present on the raw cabbage leaves, which are done in industries, then they go for the commercial starter cultures. Otherwise, if you go for traditional preparation of sauerkraut, there's no pasteurization, there's no refrigeration, and there's no addition of starter cultures. And sometimes you can go for back slopping. What is back slopping? That is from the initial, like how you do a curd preparation. That is, already you will have some curd, and from there you take it and put it into your fresh milk. Same way, you take a little bit of cabbage, that is little bit of sauerkraut, and put it into the fresh cabbage. So this is called as back slopping. Okay. Now coming to the methods. So this is a very simple method. So what you do is go for the fresh cabbage as mentioned, de-leaf it. So you remove the external leaves. You find out for the leaves which are healthy, and get the important leaves. You cut them, trim them, make them shreds. So again, shredding depends upon different companies. Some companies make it want longer. Some companies want it very minute. So around the shredded cabbage is around 2 to 5 millimeter thick. Then the most important thing which you need to remember here is the salting. So not more than 3%. 3% is the maximum salt which you should add. If you add more of a salt, the sauerkraut will turn completely sour and you cannot have it. So the amount of salt which is maximum which can be added is 3%. That means when I told you that we have to make a layer by layer, you have to see that if you have 100 grams of cabbage, then you cannot add more than 3 grams of salt. So total amount, not the one layer wise, so total amount of salt which needs to be added maximum is only 3%. So you have to manage in such a way that whenever you're doing the salting, so you have to adjust accordingly. Okay, once salting is done, you fill it in the company wise. If you go and fill in the wooden vats, so simply stuff them in and close them with a wooden block on the top. Ferment it for 18 to 20 degrees Celsius. Normally at the room temperature you keep. So It can be around 2 to 3 weeks, or it can be again more than a month, depending upon your content. And then pasteurization is again optional one. Normally you don't go for pasteurization. Pasteurization or refrigeration is normally done if you want to package and sell it. So you have to keep it in a condition which does not allow any spoilage organisms to be spoilage organisms to multiply, or even the lactic acid bacteria to further multiply. So it actually stopping the lactic acid fermentation here. And then you go for the packaging. So coming to the first one, the shredding and the salting. So as I mentioned, the outer leaves of the cabbage are removed. Any spoil leaves are also removed. You need to really wash them. So the cabbage, complete cabbage is washed, because there might be small worms, there might be small insects, and there might be even microorganisms present. So you need to wash them out, and you take the core, you cut the complete cabbage, and you shred it. So the shredded cabbage is called as the slaw. Slaw is completely shredded cabbage. And now then the shredded leaves are weighed. Why we talk about weighing here? As I mentioned, if you don't weigh it, you will not come to know how much of salt you need to add here. So you have to weigh what is the amount of shredded leaves, and then you put it into your tank. So you can either put in your carts, or as I mentioned, the bottles. You have to make into layered, and then you add your salt. So sometimes in wooden vats, what they do is they simply stuff the cabbage, put inside, and then put the required salt and close it. Otherwise, you can what you can do is, if you have a small quantity, which you can do is you can prepare in layers. As I mentioned, one layer of cabbage and salt, one layer of cabbage and salt. So like that, you have to prepare, and you close it by using wooden blocks, and then you allow for fermentation. Now, what is the percentage of salt which you mentioned? I mentioned that maximum it is 3% of salt which needs to be added. And salt content is very important in sauerkraut preparation. So the taste, the sourness, the quality of the sauerkraut is all based on the salt percentage. So if you add very less amount of salt, then fermentation might not be proper. And if the salt is not properly distributed, again, fermentation is not proper. So some parts of the cabbage might have got fermented. Some parts, some areas of the shredded cabbage might not have got fermented. So again, and if you add too much of salt, that is also a problem, because too much of salt can increase the lactic acid fermentation. So salt addition is very important. Once the salt is added, as I mentioned, you need not add water, because the salt extracts the water from the cabbage. So that itself will result in fermentation. So salt and the water will get mixed, giving you a brine, and it will also start releasing some nutrients from the cabbage. And this is the point where the fermentation takes place. So once there is a sufficient amount of water and salt and the cabbage which is present, the microorganisms will start working. So as I mentioned, salting is very critical to give you a good quality sauerkraut, and not more than 3%. So normally the range is around 2.25% or 2% also. So you cannot have more, I mentioned salt less or very high. And what are the purpose? What are the functions of giving you or what are the functions of adding salt? One, the salt extracts moisture. So it extracts water, it extracts the water from the cabbage, and it gives you the brine. In the brine, you will have the microbial fermentation take place. Second one, the salting also inhibits some microbial flora. So there will be many pathogenic microorganisms which are present on the cabbage. So these can be inhibited with the help of the salting step. So for example, pseudomonas, which can cause spoilage. The third advantage of salting is it can maintain the crisp texture of the cabbage. So when you take it after, for example, three weeks or so, when you take it and you eat it, it will give you a crispy cabbage. So that is because the brine fermentation or the addition of salt releases the water from the cabbage. So when the water is released from the cabbage becomes more stiffer, more crispier. And it also inhibits any of the proteolytic enzymes from the microorganisms, which can cause, again, spoilage. And fourth, salt gives you the flavor. So we already know that salt obviously gives the flavor to any type of dishes. Forget about sauerkraut, even simple dishes we are making at home. If there's no salt, you will find the difference. So salt itself gives you the flavor of the product. So these are the four functions of salt. Extracts moisture, prevents microorganisms, maintains the lactic acid or crispiness of the texture of the cabbage, because the water is being removed, and then it also gives you the flavor of the product. The second step is stuffing. So once shredding is done, salting is done, then you go for stuffing or filling. So you can normally done is traditionally it is done in wooden vats. Nowadays you have a lot of steels and not wooden tanks or wooden vats are not used much in industries. But in traditionally you have wood stave tongues, and if it is industrial, normally they have concrete vats which will be having some either plastic, or they'll be having glass or even steel. So you stuff your cabbage which is salted into it, and you mix it properly, so that you don't have any cabbage or salt which is present on the surface or walls of the vat. Then you can it is okay, this it's not water, or it's a weight actually. The spelling mistake what I did. So weight is placed on the top of the cabbage which I mentioned. So when you do the cabbage, prepare the cabbage, close it down, and you keep lots of heavy weights on the top. So what does it do? It excludes the air, it excludes any pathogenic microorganisms to present, and anything which dust particles which might be, they having some spores might be present on the dust particles, they will not come and settle down. And this also helps in the release of water from the cabbage, and so that salt and water mixes gives you a brine. Okay, so that is a second step called as stuffing or filling. So this is how it looks like. This is what you do it in the companies. So you can see here, this is the fiber, the plastic vats which they have it. So they would have stuffed the cabbage inside it, and on the top they have kept the wooden blocks. This is another picture where a big large ton or a tank which is filled with your sauerkraut and salted cabbage. Okay. The third one, so once the water is released from the cabbage and it mixes with the salt, it gives you the brine, and this brine initiates the microbial fermentation. So this has a lot of lactic acid bacteria, and most common bacteria which basically works on sauerkraut is Lactococcus and Lactobacillus, Lactococcus and Leuconostoc and Pediococcus. So these are more four groups, and in that the predominant group which you find is the Lactococcus and the Leuconostoc, especially the Leuconostoc mesenteroids. This is one of the very dominant group of organisms which is found in the sauerkraut fermentation. And one interesting phenomenon in the sauerkraut fermentation is there is a sequential growth. So there's not that all the microorganisms will grow at the same time. So there is a sequential growth. So one after the other. So there's a successive fermentation which takes place during the sauerkraut preparation. And the condition is so optimum in the sauerkraut fermentation that only these type of organisms can grow here. So you will not have any pathogenic microorganisms grow here. And the entire fermentation is basically divided into 3 stages: the first phase, second phase, and third phase. So this phase is basically to attribute, or it is to show that what organisms come in the first phase, who succeeds them in the second phase, and who succeeds them in the third phase. So as I mentioned, during fermentation, there is a sequential growth of these bacteria. So the presence of 2.25% of salt, which we have added, and low fermentation temperature, large amounts of sugars, absence of oxygen, all these are facilitating the Leuconostoc mesenteroids to grow rapidly. So salting, absence of oxygen, lot of sugar to be utilized, and temperature is low. So these 4 conditions are actually driving the Leuconostoc mesenteroids to grow rapidly. Now coming to the first phase, anaerobic first phase, in this the very less important microorganisms like Klebsiella and Enterobacter will come, because they might be already present in the cabbage. So they will be present in the, and they will be utilizing the sugars for fermentation and begin produce an acidic environment. So at that point the pH becomes less, and that pH, if you are very careful in the first phase itself, you will see that the low pH will start favoring the growth of the organisms which are supposed to come in the second phase. So second phase is important for the most important organism, that is Leuconostoc mesenteroids and some other Leuconostoc species. So that is because of the high level of acid. So fermentation has started taking place. In the third phase, the Lactobacillus species will replace the Leuconostoc. So first Klebsiella enterobacter, second phase it is leuconostoc, third phase it is lactobacillus species. In lactobacillus there are two species which are commonly dominating this third phase, that is brevis and plantarum. So whatever sugars are left out, so second phase already there will be an extensive fermentation taking place by leuconostoc mesenterites. So any sugars which are left out, so by the time acid level will be too high, and by then the lactobacillus will come up and will do the remaining fermentation, and that will also increase the pH of the sauerkraut. So as I mentioned, the second fermentation, which is also called as a kraut fermentation, is initiated by the leuconostoc. It is a heterofermentative species. Heterofermentative means it can produce not only lactic acid, it can produce acetic acid, it can alcohol. So the end product is only not lactic acid. It is more than the lactic acid. So it produces acids, as I mentioned, lactic acid, acetic acid, and also it produces carbon dioxide. So that carbon dioxide is the reason which I mentioned that the lid can come off. And that is the reason why we have to keep the lid closed completely using heavy weight. So it releases carbon dioxide, it can lower the pH, and undesirable microorganisms will not grow. And the carbon dioxide will replace oxygen which is present inside the bottle. It can prevent anaerobic condition. It can create an aerobic condition, and it can prevent any utilization or oxidation of any type of molecules. It can stimulate the growth. So all these are happening in the second phase. The third phase, we have the Lactobacillus brevis and Pediococcus, or Lactobacillus plantarum. So Lactobacillus brevis is heterofermentative, again, which can produce more lactic acid as well as acetic acid. Homofermentative means they can produce only lactic acid. And sometimes the yeast called as Pediococcus cerevisiae, which can grow rapidly, and they can also produce acid end products. And here also the acidity is higher. So if you see here in the second phase, the acidity is higher, but not very high, or it is almost like what do you say, the 10% or so, or 5% of the lactic acid is produced. But when it reaches the third phase, the lactic acid is around 1%. And when the acidity of the sauerkraut product reaches 1%, at that time, the second phase, the leuconostoc mesenteroid slows down. So it stops utilizing the sugars, slowly stops down. And that point, the Lactobacillus brevis starts coming up. So they're already in the cabbage leaves, they'll start growing up. And they will also continue to form in sugars when the lactic acid content goes to 1.5%. When the lactic acid content is 1.5%, then Lactobacillus brevis gets replaced by Pediococcus pentosius. And they will increase the acidity to around 1.8%. Okay, so the Pediococcus pentosius, takes up from Lactobacillus. So it's a sequential, as I mentioned, it's a sequential step which is happening in the sauerkraut. So you have the first phase, you have the second phase, and you have the third phase. The first phase, we have the Klebsiella and the Enterobacter. The second phase, we have the Leuconostoc. Leuconostoc will be succeeded by the Lactobacillus brevis. Lactobacillus brevis will be succeeded by the Pediococcus when the acidity goes to 1.8. And once it goes to the acidity to 2% or even more than that, you have the Lactobacillus plantarum. So normally we do not allow the the sauerkraut fermentation to take place more than where the lactic acid is around 3%, not more than that, because above that, if it happens, the sauerkraut becomes too sour. You cannot eat it at all. So you need to be very careful about its fermentation. And it has to be only sufficient acidic so that it does not allow any favorable microorganisms, and it can be easily consumed. Now, what is the biochemistry? What happens exactly during the sauerkraut? So I mentioned the sauerkraut is having, the cabbage is having a lot of fermentable sugars. So it has sucrose, it has hexose, pentoses, all that is going to be utilized by your leuconostoc in the second phase. And it will start utilizing all of them and starts producing lactate. It will start converting the raw material or metabolizing the sugars to lactate or acetate or ethanol or carbon dioxide or diacetyl. Because I mentioned the leuconostoc is a heterofermentative species. So it can metabolize your carbohydrates or sugars, fermentable sugars, to end products like lactate, acetate, etc. Lactobacillus brevis, which takes up from the second phase to the third phase, which is again heterofermentative. It also utilizes the remaining remaining fermentable sugars, and again it gives an indication, or it gives an indication that what are the products which are produced. It can produce lactate, acetate, ethanol, carbon dioxide, and diester. Once the salt concentration goes to 1.8%, Pediococcus 1.5%, Pediococcus pentosius comes, and then it also starts utilizing hexoses to form mainly lactic acid, because in the previous slide I mentioned it is homofermentative. So it will normally produce only lactic acid and then followed by lactic acid plantarum. So in lactic acid plantarum also starts producing the same materials like your the first three organisms. So same way it also starts producing lactate, acetate, ethanol, etc. And all these action of lactic acid, acetic acid, carbon dioxide, diacetyl, ethanol, the mixed combinations of these products only give you the characteristic flavor of sauerkraut, that is acidic content of the sauerkraut. Okay, so you will feel the sourness because of these products. These are these components. Coming to the packaging, packaging is normally done using thermal processing. So you can give heat conditions. So in industries, you go normally go for thermal processing, and especially if you're going for cans or jars, and they're more sterile and they're more stable, and there's low risk of spoilage. Sometimes the sauerkrauts are also not pasteurized, not refrigerated. So that is a traditional way, non-pasteurized and refrigerated, but nowadays companies are modifying them, and they are doing a lot of extensive preservation techniques to increase the sauerkraut shelf life. And you also have one way of producing this sauerkraut. These are having a long shelf life. They provide antimycotic agents. So I mentioned these. We will talk about the health benefits in the next slide. So they have a long shelf life. They provide antimycotic agents. That is, they are anti-fungal, like for example, which contains benzoate and sulfide acids, and they're added, and the product is cold. So this is the packaging mechanism, mostly during the thermal processing. Coming to the spoilage happens only if you do not take care of the temperature at which you are keeping it, and also if you are adding too much of salt or less of salt. So the two most common factors that influence the fermentation is quality, the temperature and the salt. So if the temperature, as I mentioned, if the temperature is too high, and if or the temperature is too less, it can cause problems. If the salt is too high, if it is more than 3%, you will not have the leuconostoc mesenterics working upon. If you have less salt, then you will have some organisms which can tolerate the salt to a particular extent. So initially we are adding 3% of the salt, right? So maybe if you're adding 1% for the overall salting, so there might be organisms which can tolerate 1%. So they will start growing instead of your leuconostoc or lactobacillus. Okay, so you have to be very careful with the temperature and the salt. So as I mentioned, these are the only two factors which can induce spoilage. So if the temperature is too high or the temperature is too low, you can have conditions, because already you know that as per the because of what I was telling about the temperature and the salt. So because of fluctuations, because of problems in weighing the salt, all this can cause problems in sauerkraut production. So this sauerkraut production can result in spoilage of bacteria like Enterobacter, Flavobacterium, Pseudomonas. They might be naturally present on the leaves of the cabbage, because you're not going for pasteurization step also. So it can cause you a problem, or can cause a defect or a spoilage called as soft kraut. Soft kraut means there is a softness of the cabbage. Cabbage becomes soft. It can give you the crispiness of the cabbage does not happen, because there is a lot of enzymatic productions. Enzymes getting produced by microorganisms. They can break down the pectin which is present in the cabbage, and they can make the cabbage salt. So main two important things which you need to remember is temperature should not be too high, or temperature should not be too low. It should be normally between, in room temperature, somewhere between 18 to 25 degrees Celsius. And salt should not be too less, salt should not be too high. So salt should be not less than 2 and not more than 3%. So if you are maintaining these two things, sauerkraut can come out fine. Coming to the health benefits, so as I mentioned the first part, that fermented vegetables have their own benefits, because first it can give you high digestibility. It is a high source of vitamin C and K. Sauerkraut is a good source of vitamin C and K, and the fermentation increases the release of the nutrients, the bioavailability of nutrients. So sometimes if you have simple cabbage, especially with normally we have a misconception that raw vegetables are good source of nutrients.